All right, chapter 2.6, we're going to be talking about similarity, similar figures. So similar figures are basically figures that have been dilated. So we talked about last time this idea of rigid motions, and we listed the rigid motions as translations, reflections, and rotations. A similarity transformation is a dilation or sequence of dilations and rigid motions. So the key here to assimilate, the key difference is that a dilation occurred. So similar figures down here, what we're looking at is, as you can see, this triangle here is just the smaller version of this enlarged triangle over here. And what you find is that when you dilate, whether you're enlarging or reducing, you're going to have this. You're going to have similar, corresponding. They're going to be congruent, or I'm sorry, they're not congruent, but they're going to be similar. So all of the sides, corresponding side lengths, are going to be similar and proportional. So that's hopefully that should be springing words, proportional. So the way we're going to solve these is using proportions. So little spoiler alert there. But all of the angles, these angles and these angles, no matter how big I make this triangle, all of my angles are going to remain congruent. Congruent means equal, okay? So if this up here was, I don't know, what does that look like? 50, let's call it. If this was 50 here, then this was 50 here, okay? If this was 30 here, then this was 30 here. And since we add up all of the, since the interior angles all add up to 180 degrees, pause the video, see if you can figure out what the other angle is while we're at it. Hopefully you figured it out as, pause, 100. Because 100 plus 50 plus 30 is 180, which is what they add up to. So there's a little side lesson. Okay. So this little symbol, so the side lengths here, as you can see, all they're saying is the red matches up with the red. So this corresponds to this. This hypotenuse corresponds to this hypotenuse, and this this bottom green one and you see that they have equal signs. Well, this little wavy thing that goes on top of there is similar. Okay, so we draw that with just equal sign and then a wavy line on top. And that simply means similar to. So angle A and angle D. So angle A and angle D are similar, which also means congruent. Okay, so moving on. Okay, so again, I feel like this chapter doesn't do this justice of what I would actually teach if I were teaching this. But so they want you to be able to determine whether it is similar, and the only way is if everything multiplies by 2. If this was multiplied by 2 and this was multiplied by 3, it would not be. Okay, but since all of these were just multiplied by 2, then it is a dilation. So therefore a dilation only, or a dilation and then a movement. So we talked about that last time. Those still remain similar. Okay, so describe the similarity transformation. Okay, again, not really super excited about how they have this, but basically what they're showing is that this thing here, it flipped about the x-axis or rotated about the x-axis, and then there was an enlargement. Or no, they're saying we went from the red. So from red, you would figure out what this point was. Okay, so this point was 4, -2. So this point became, instead of 4, it became 2. So that's times 1/2 or times 0.5. And then the other point was 4 -2 would have been divided by 2 would have been 1. So the scale factor of 1/2, that's how you determine that. And then they mirrored it or reflected it across the x-axis. And remember, when you're reflecting across the x-axis, you're changing your y to the opposite. Okay, so now we get into actually what I believe should be the most important part of this chapter. It seems to be an afterthought, so we'll see how the homework plays out. But an artist draws a replica painting of that. Draws a replica of a painting that is on a remaining piece of the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3.75. What is the height h of the trapezoid in the replica? Okay, so all this is saying is this is what it was, this is the replica, and therefore the corresponding sides are going to, we can put them into a proportion. So remember, proportions, we're going to set one thing equal to another. So let's just say that the 15 inches corresponds to the 3.75. So 15 on top, 3.75 on bottom. And let's do, remember, I always like to do this, so I should have done this, but just this is the painting and this is the replica. So the replica has the variable, right? So on the replica side, we're going to put the h. The painting had 15, and this corresponding side is 12. Okay, then we just cross multiply, and I don't have my calculator, so you're just going to have to, we're not going to wait for that, but you would multiply 12 times 3.75, and then we would get 15h is equal to 12 times 3.5, and then we divide by 15. Sorry guys, I'm not going to redo this because I forgot my calculator. You can figure this part out, and as always, if you have questions, let me know. But the key is to line up your proportions, solve for h, cross multiplying. So just to be clear, this is 3.75 times 12 and whatever that is, and then we would divide both sides by 15. And that would give us h is equal to this here, whatever that equals, 3.75 times 12 divided by 15. All right, hopefully that was good. Like I said, if you have questions, let me know. This is a pretty straightforward chapter section, so see ya.